So hello guys, with the name of God Ram Ram, I'm your favorite DSA plus OA plus CP teacher Kumar and today we are going to solve some of the problems of Leetcode Weekly Contest 445. We start everything always with the name of God. So the strength of God and the energy of God is always in us, okay? Without God you cannot achieve anything in this world. So Ram Ram. So guys, this is a short analysis video. Okay, like what is the difference between my short analysis videos and the deep analysis videos? Generally, in the short analysis videos, I just tell you the logic and the solution. I don't deeply discuss the intuition, the deep analysis, and the deep edge cases XYZ XYZ XYZ. So in the short analysis, we'll try to go through each problem very quickly. This video is for the people who already know DSA and mathematics at a good level. Okay, so those people can watch this video. The deep analysis video anyone can watch, because in the deep analysis video I do everything from scratch for the viewer watching it. Okay, but now students quickly want the solutions for this, so let's do the short analysis pretty quickly. So the first question is this one, which is the first question is the find the closest person. Okay, so guys, you are given three integers x, y, z representing the position of three people on a number line. Okay, so guys, they are saying that a number line is given to you. Like, this is the problem A, which is pretty simple. A number line is given to you. A person is at position x, another person is at position y, another person is at position z. So they are saying which person is closer to z. So you will calculate the first distance, right? This distance is what? D1. And this distance is what? D2. So if D1 is strictly less than D2, if D1 is strictly less than D2, which is not the case here, D1 is strictly greater than D2, right? If let's say D1 is strictly greater than D2, then you can say that the person X is closer, person Y is closer. If D1 is strictly greater than D2, means this is a smaller distance. It means Y is closer to Z. So if D1 is greater than D2, person Y is closer. But if D1 is less than D2, person X is closer. And what if both are equal? It can happen na, that the distance is equal. In that case, you will print a tie or something like that. For example, basically guys, I hope you got the point here. The point is that you are given a number line. You are given a number line like this. Z is somewhere, X is somewhere, and Y is somewhere. Let's say this is the distance D1 and this is the distance D2. They are asking which guy is closer to Z. Is X closer to Z or Y closer to Z? They will be traveling with the equal speed towards Z. So who will reach first? It totally depends on the distance, right? Because the speed is same. So if the distance of both of them is equal, the distance from X to Z is equal to distance from Y to Z, then the answer will be a tie. So guys, the problem solution is simple. You will calculate D1 and D2. How to calculate D1? It is nothing but absolute difference of X minus Z, and D2 is to handle the negative part also, because you only need a positive distance. Is Y minus Z, and then just compare and the problem is done. Like, the implementation is also super easy. If this distance less than this distance, return this. If both are equal, return 0. Done. This is like a kind of a baby problem. Let's go to problem B. This is a really interesting problem. Really interesting one. So, yes, guys, I love teaching and training students. Okay. This year we have had many, 25 to 30 Fangam selections also. So, congratulations to our student Abhirami for cracking off campus 50 LPSD offer from Amazon. Okay. She has worked hard since a year with us in the daily life DSA plus OA plus CP training, and used the off-campus job search training and referral support in the best way possible. And she was my favorite one-to-one mentoring student. She ended up getting selected. So congratulations to her. If you also want to be the part of us, you can check this link. Now, guys, problem B. Guys, they are saying that you are given a palindromic string. Find the smallest palindromic permutation of S. Okay, so hopefully you guys understand the meaning of permutation and all that. Anyways, I will give you an example. So guys, they are saying that a palindrome is given to you. Hopefully you understand that a palindrome, if this is a palindrome, then what is going to happen? Let's say this is a palindrome. This character should be equal to this character. This character should be equal to this character. A, B, B, A. Is this a palindrome? Yes. First is equal to last and second is equal to second last. Okay. So they are saying that we are giving you a string, bro. Okay. Z, Z, B, B, let's say A. This is the palindromic string given to you. They are saying convert it to a palindromic string, but it should be lexicographically minimum. It should be lexicographically minimum. Lexicographically minimum means what, you know? This first character should be as small as possible. Once you fix the smallest character, this also should be as small as possible. So guys, what can you do? Instead of Z, you can put a smaller character first. Then you can put a B. If you put a B here, you are forced to put B here also. And after B, you can put a Z here, right? If you put a Z, you have to put Z here. Then A. So guys, I hope you understand the mirror image concept, that if you fix the first half, the next half is fixed. So basically guys, nothing to do. Take all these characters, sort them, and start putting the smaller characters at the start. That is the solution to this basic problem. Like, I will give you few more examples to test your power. What will you do here? This is the string given to you. You have to convert it to lexicographically minimum. First of all, you should know the hashing concepts. You will store all the frequency in a hash map. So guys, I will create a hash map, looks like this. Hash map will, and make it a sorted hash map, okay? Hash map will say that, hey sir, A is coming 2 times, sir, B is coming 2 times, sir, C is coming 2 times. Now you will construct the new string. Now you will construct the new string, guys. Now you'll construct the new string, okay? So how will we construct the new string? Let's think about that. Well, listen to me very carefully. You have to put these guys only here, but the first guy should be the smallest guy. And you are using the sorted hash map, right? The first character A is the smallest guy. You can see A is coming 2 times. What will you do? You will write a here, and because you write a here, one A will come here also. Done. Yes. So now after you have done this, A is now coming 0 times. So whatever is coming 0 times, remove it from hash map. Now you come into the next character. Here what will I put? I have B and I have C, but I will only use the first character of the hash map. Why? Because B is smaller than C, na? Everything is in ascending order here. So B is coming 2 times. I will write B here. And because I've written B here, forcefully I have to write B here also to make sure it is a palindrome. Now B is coming 0 times. It has been used, right? So B is coming now 0 times. Remove it from the hash map. Then C, sir. C is coming 2 times. So one C I will write here and one C I have to write at the same place. We have the lexicographically minimum string. You just have to be careful when the things are coming odd number of times. At max, only one character can come odd number of times in a palindromic string if the length of the string is odd. So this much concept you must be knowing, right? You are a Kumar student watching his videos, right? So I will give you one more brilliant example to make things very, very clear to you. Let's say this is given to you. Ram Ram. Now what will you do? D, D, A, 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 B, 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 C, C. How will you convert it to lexicographically minimum one? You will first create a sorted hash map, right? Sorted hash map will say that sir A is coming three times, sir B is coming sir four times, sir C is coming sir two times, sir D is coming two times. What will you do here? First character is A. I need A two times. I need A two times, but I see it is an odd number. No problem. I need A two times, right? So I will write A here. The first character should be minimum one, right? In lexicographically minimum. And then a here. So now what will happen? Now you can say that A is coming one time. But you will write a special condition. If some character is coming one time, it means you need to add it in the middle. So now what will you do, lovely student? You will add a here. There is no other option. Because this A is coming one time only. And palindrome has, all the characters coming generally two times. If someone is coming one time, it needs to go in the middle. Okay. So you put it in the middle. So now A is coming zero time, it has been solved. Now you can go to the next character here. So when you go to the next character, what will you do? A has been used, you remove it from the hash map. Now B is coming four times. You need your B only two times. You need your B only two times. You need your B only two times. So I will write a B here and I will write the same B here. So now I can say 4 minus 2, B is only coming 2 times. I come to the next character. B is coming 2 times, so I will use it. B here, B here. Done. Now B coming 0 time. Then C. C is coming 2 times. So 1 C here and 1 C here. C is now 0. Then D coming 2 times. 1 D here and 1 D here. D now coming 0 times. Solved. Problem is solved, guys. Problem is solved. So hopefully you like the solution. All you have to do is maintain a sorted hash map. Then go from, you have to go from, left equal to 0 till n by 2. You will go till the middle value. Okay, you will go till the middle value. From left till the middle value you will go. And you will just keep the decreasing the frequency by 2 to 2 and please take the care of the odd case. At max one character can have odd frequency. Whenever it is 1 you put it in the middle, and whatever the other characters are you are doing in a sorted order, so it's the minimum characters on the left hand side, but the right hand side already is fixed because in the palindrome this character should be equal to this. So in the palindrome, if you have decided the left part now, the right part is already fixed. It will be the mirror image of the first half. Okay, so hopefully you guys enjoyed this. Lovely, lovely, lovely. Be very happy in life. Don't be depressed and sad. Be very happy. Listen to your parents and love your mother and father. Now, going to the next problem, guys. Problem C. Problem D is a very difficult problem, so I will take it in the next deep analysis video. Make sure you write in the comments that you need a deep analysis video. If you write it, then I will take the deep analysis of problem D. For now, let's go to problem C, and you can check the implementation of problem B. So guys, problem C is same as before, but there is a problem here. What is the big problem? They are asking you the kth palindromic permutation out of all the permutations possible of the given palindrome. Don't worry, just relax. Calm down, calm down, calm down. Let's say this string is given to you. How many palindromic permutations are possible for it? Like in how many ways you can rearrange this string so that the final answer is still a palindrome? So one possible answer is BAA, another possible answer is ABA. Okay. Only one way is possible, right? BA is not a palindrome at all. This is not a palindrome at all. So let's take some better cases like, So now, how many ways are there to arrange it in a palindromic fashion? BBAA, one way. Second way is AABB, AABB. Okay, you can imagine it like that, and you can just enjoy as much as you want to enjoy. And then another way is AABB. Another way is BBAA. So, guys, for now, you can see that there are four ways to do so, right? First way to do, second way to do, third way to do, fourth way to do. Now, what to do? So, they are saying that you consider all the palindromic permutations possible. Basically, this is a palindrome. There are four more ways to write it as a palindrome. Now, guys, you have to arrange it in a lexicographically graphic order. These are the four ways, guys. Who will get the rank number one in this? Which one is lexicographically minimum? The one which starts with smallest character. No, no, B is not. This cannot win. This cannot win. Both are starting with A. So check the second character. This is A, this is B. So this one is the smallest guy. So guys, if you arrange them in rank order, na, A, B will be the lexicographically minimum first ranker. Then A will be the second ranker. Then B will be the third ranker. Then BBAA will be the fourth ranker. So guys, these will be the ranks: AABB, ABBA, BAAB, BBA. They will give you a K. K can be anything from 1 to 10 raised to 6. They will give you a K. K can be anything from 1 to 10 raised to 6. Let's let's say for this string they give you K as 1. So what will you do? Out of these four palindromic permutations, which one is the smallest ranker? Which is the first ranker? Sir, this is the first ranker. So your answer will be AABB. We know how to find the first ranker, lexicographically minimum. But what if they ask you the second ranker? Now what will you do? Will you sit and cry? No. Second ranker is ABBA. So if they ask you second ranker, the output will be ABBA. What if they ask you? What if they ask you the third ranker? This is the string which is the third ranker, which is the third lexicographically minimum. Third ranker means third lexicographically minimum palindromic permutation of BBA. This one it is BAAB. Bap. Bap sabka bap. Which is the fourth palindromic lexicographically minimum permutation. This double B double A. Guys, I hope you understand why this is ranker 1. The first ranker will have the minimum characters at the starting places. See AA. Like a dictionary order, guys. Then ABBA, then BAB. See, these both are in A, these both are in B. So hopefully you understood, guys, that I give you any freaking string. Your job is simple, baby. Your job is just to relax. Don't take any extra stress. Just relax. Just relax as much as you can. Just detoxify and relax. Okay. So, guys, in this particular question, I'm sure it is clear to you that given a palindromic string, you can first try to use some maths and calculate, how many palindromic permutations are there. You can store all the palindromic permutations in a sorted hash map, and you can print the kth index string, right? But this is it will give you TLE, because there can be millions of palindromic permutations of the given string. So you cannot store all of them. So what you can do is you can just enjoy your life, just relax and just enjoy. Okay. Let me take a string like AAB. Okay, AAB. Okay. Let's say this string is given to you. Okay. Or let's take some another example, right? Now, how will you analyze this particular situation? There can be many palindromic permutations, first of all. How will you know the total number of palindromic permutations? So what you can do is you can decide the first half, right? You can decide the first half. What can you put in the first half? What can you put in the first half? So you know your A is coming 4 times, your B is coming 2 times, right? You know this thing. I also know this thing. Let's consider even length strings only. When it is a odd length string, the middle character, it is a odd character, and you need to put that character there only. There is no other way. So guys, A is coming 4 times, B is coming 2 times. But guys, I only want to know the permutations of the left hand side. Means for the first three characters. Because whatever are the first three characters, they will be equal to the next three characters. So guys, how many ways are there to fill the first three characters? For the first three characters, I have my A coming for 2 times, baby. And B coming for 1 time, baby. Okay. Okay, sir. So guys, what will you do? Let's say you have an even length string. You will write all the frequencies here in the hash map, and now you will divide everything by 2. So now you can say A 2 times, B 1 time. Basically, you can put here A 2 times and B 1 time. So guys, how many ways are there to put A 2 times and B 1 time? If I tell you that I have 2 A's and 1 B, how many times, how many ways can you fill the first half? You can say na sir A, or I can put B, or I can put A. There are 3 ways. First way, second way, and third way. How can I write these ways? Simple mathematics, guys. In the permutation and combination, it was taught to you, right? It is clear that you have 2 A's and you have 1 B. 2 A's and 1 B. So how many way rearrangements are possible? Total 1, 2, 3. Length of the string is what? 3 factorial. Divided by how many times 2 is A is coming? 2 factorial. Multiplied by B is coming 1 factorial. I will use this formula and my problem is solved. Just use this lovely formula and your problem is freaking solved. Immediately using this formula, you come to know how many permutations are possible for the first half. And if you know the number of permutations of the first half, the next half is already decided. It will be exactly equal to the first half. तो गाइस अब तुम ही सोचो कि फर्स्ट हाफ को भरने के कितने तरीके हैं. सर फर्स्ट हाफ में सर ए 2 बार आ सकता है, सर बी 1 बार आ सकता है. ठीक है, तो टोटल तरीके कितने हुए? इनका सम क्या होता है? 3 फैक्टोरियल डिवाइड बाय 2 फैक्टोरियल डॉट 1 फैक्टोरियल, विच इज व्हाट? 3. Means guys, there are 3 ways to fill it up. So you can write this range as 1, 2, 3. There are 3 ways to fill it up. और सच्ची में 3 ही तरीके दिखाऊं तुमको? You have to fill the left half. You know that you can use A 2 times and B 1 time. By using the mathematical formula 3 factorial by 2 factorial dot 1 factorial equal to 3. There are 3 ways. 1 way, 2 way, 3 way. Which are those 3 ways, guys, by the way? One will be AAB. Another will be ABA. Another will be BAA. Wow, 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 wow. Let's say they are asking you for k equal to 3. They want the third ranker. They want the third ranker. They want the third ranker. You just know that there are 3 possibilities. After this mathematics, you will know 1, 2, 3. There are 3 permutations possible. But you don't know which is the third ranker. So what will you do? You will fix the first character. You will try to fix the first character. So guys, what will happen if in this AAB, I fix the first character as A? Now I am saying, what will happen if I fix the first character as A? Now what is the leftover I have with me? I have A 1 time and B 1 time. So the total is 2 factorial divided by 1 factorial dot 1 factorial. So there are 2 permutations possible. So if I fix A here, one will be AB like this and one will be BA. So I can say that yes sir, 2 possibilities are there, 1, 2. So If I fix the A, if I fix a here, there are two possibilities. Rank number one, rank number two. One is A, B, one is A. A is fixed at the first place, then A, B this and B, A this. So A, B and B, A, two possibilities. You know that you want K equal to 3. Is your 3 coming in this range 1 to 2? No, sir. So now you will try the next possibility. What if you put B in the first place? Now all those permutations will come which will be bigger than them. Why? Array, the permutation starting with B will be bigger than the permutation starting with A. Na? So now it will start from number 3. So if you put a B here, what is the possibilities here? Here you can only put two A's, right? So total is 2 factorial divided by 2 factorial. Only one possibility is there, A comma A. Only one possibility is there, A comma A. So here this was 1 to 2. This range was 1 to 2. And this range will be 3 to 3. You can use mathematics now. Recently for A, the range was ending till 2 if you count all the permutations which start with A. So the permutation which start with B will start from 2 plus 1, 3. And you know there is only one such permutation. So 3 plus 1 minus 1 is the end range, 3 to 3. So guys, you found it. The permutation which starts with B is the answer. B, A, A. Like this you can solve any problem here. Wow. I will show you one more final example and done, 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 done. I was just trying to show you the core logic. So guys, you just have to find the permutations possible for the first half. Why? Because the second half will always just be a copy of the first half. So just divide all the frequencies by 2, right? This much maturity should have by now. So now let's say this is given to you. Okay, so first of all, what is the hash map will say that A coming 4 time, B coming 4 time. But you are only considered about the first half, right? Okay, and the K, okay, you are only considered about the first half. So now the hash map divide all frequencies by 2. I hope you understand why I'm dividing by 2, because whatever you add here, you have to add in the next half also, which will be same. So how many permutations are possible for the first half? That's the answer. Total length is 4 divided by 2 factorial dot 2 factorial. 4 factorial divided by 2 factorial dot 2 factorial is, guys, ये आपको ना पता होना चाहिए. Like if A is let's say coming 3 times, B is coming 5 times. So how many ways are there to, how many permutations are possible? It is 3 plus 5 factorial divided by 3 factorial dot 5 factorial. If you don't know this, then you just go and ask to ChatGPT and Google that given 3 identical items and 5 identical items, how many ways are there to arrange them? It will say 3 plus 5 factorial divided by 3 factorial dot 5 factorial. Okay. So here A coming 2 times, B coming 2 times. So 4 factorial divided by, so 4 factorial is 24 divided by 2 to the 4, 4 on the 4, 6 to the 24. 6 ways are there. So you know that for this particular sequence, there will be 6 permutations. 1, 2, 3, 4, 5, 6. You know that. Let's say K is equal to 5 they have asked. Okay. Now how will you find the fifth ranker permutation from in the dictionary order? I will first count all the permutations which start with A. I know the total range goes from 1 to 6, but what about the guys which start with A? If I'm considering the guys which start with A, then my range will go from, what will be the leftover part, guys? A coming 1 time, B coming 2 time, 2 plus 1, 3 factorial divided by 2 factorial, 3. There will be 3 possible sequences. There will be 3 possible sequences. 1, 2, 3. So I can say 1, 2, 3. There will be 3 possible sequences. Now, what if I start my permute, or which are the permutations which start with B? So if I put a B here, now the leftover part will have A coming 2 times, B coming 1 time. So it will be, if I fix a B here, B will come here for sure. So the leftover part has A coming 2 times, B coming 1 time. How many ways are there to rearrange the leftover part? That is the total number of permutations starting with B, right? So 2 plus 1 factorial dot 2 factorial dot 1 factorial is 3. So again 3 are there. If you, I even want to count all the permutations starting with B, there are again 3. So this was 3, so it will start from 4. 4, 5, 6. So guys, now you have two options. You have traveled all the, like in this case, you have traveled at the first index, you try to put A, B, C till Z. We have only A and B, so we are only trying A and B, okay? I was just giving you the hint of the general algorithm. So I try with A, I try with B. If I try with A in ascending order, I know these three permutations are possible. If I start with B, the next three lexicographically permutations will be 4, 5, 6. But guys, the question is saying I want K equal to 5. So K equal to 5 lies in which range? Does it lie from 1 to 3 or does K equal to 5 lies in 4 to 6? 4 to 6. So you forget this part. Answer can never be start with A. The fifth ranker permutation can never start with A. It will always start with B only. It is one of them. 4, 5, 6. You have to find the exact one. So now you can say that, sir, it is confirmed that at this place you need to put a B. Because if you put a B, then the permutations which have rank 4, 5, 6 can be generated. And we want the permutation with rank 5, baby. So now, the next character. Now what to do? B is fixed, guys. B is fixed. So how many permutations possible? 3, you know that. Now, guys, next character you have to decide. Now, in this case, your hash map looks like what? A coming 2 times, B coming 1 time. Guys, what if I try to put a A here? Let's say I try to put a A here. What will happen? If I try to put a A here, the updated hash map will be what? The leftover values will be A comma B, which I can put here. 1 plus 1, 2 factorial by 2 factorial. Only two ways will be there. If I put a A here, there will be two possibilities. 4 to 6 will be divided in 4, 5. So guys, if the first character is B, which we have already fixed, the second is A, it can give rise to two permutation, 4 and 5. First is B, we have fixed. What if the second character is now B? Now the leftover is what? A comma A, which is 1 plus 1, 2 factorial divided by 2 factorial. Only one way is there. Only one way is there. If the first character is B and the second is B, there is only one way. So the next after 5 is 6th. So guys, which one will we take? Will we go with BA part or will we go with BB part? We want K equal to 5. Can 5 come in 6? No. So we forget the BB part. We want 5 comes in the range 4 to 5. So we will go with the BA part. So now guys, we go with the BA part. BA part. Now we know that after all this hassle, we know that all the permutations of the first half, if here there is a B and here there is a, it is sure that these permutations are coming on rank number 4 and rank number 5. We want rank equal to, we want to know the guy who is at rank number 5. Now what will you do? You have to select the third candidate now. What is left over now? A coming 1 time, B coming 1 time. Total 2 possibilities. That's why 4 and 5. Now what? Now what? Will you cry? You will sit and cry? No, baby. No. Now, A coming 1 time, baby. And B coming 1 time, baby. Okay. So what will you do, bro? LeBron James, Michael Jordan. And again, you will try both of them. What if I put A here? Then only B will be left. One option. Only one option. So if I put a A here, BAA, this will give rise to fourth guy. And if I put B at the third place, again one option only of putting A. This will give rise to the fifth option. Which one I want? Fourth one or fifth one? Fifth one, guys, we are able to reach the final range. So BAB dash is the final answer. And you know what to put here. You know that A was coming 2 times, B was coming 2 times, B has been used 2 times, A has been used, so A will come. BA is K equal to 5 answer. Guys, done. The algorithm is clear. What do you have to do? If you are given an odd length string, just make sure you put the middle character there and you forget about it because the character having odd frequency will come in middle. And now treat it as an even string and solve the problem. So we can assume we have an even string. You have this hash map. You will divide by 2 and you will create new hash map. Now for this string, you have to decide the first half. So first you will go here. You will try to put all types of characters A till Z. You will see which character gives a range L to R such that our K is in that range. Once that is decided, we will do it for all the characters until we reach exactly K. So guys, the problem is solved. We just need to be careful about the overflow. The permutations which we have now, the permutations which we have now, they can be as large as 10 raised to 10, 10 raised to 50 like this. But our K value is 10 raised to 6 only. So while calculating this factorial, now your value should not overflow. So the thing is that, like, you have understood this by now. Like, this is just a nice way of calculating. See, you know that, let's say this is a hash map. This guy is coming f1 time, f2 time, f3 time. What are we doing? We are saying that the answer is f1 plus f2 plus f3 factorial divided by f1 factorial dot f2 factorial dot f3 factorial. My only worry for you is that this value can be bigger than 10 raised to 6. In that case, you need to stop. Like, your range can be from 1 to 10 raised to 10. So what will you do? Instead of 10 raised to 10, you will cut it up and you will say that, okay, 1 till 10 raised to 6. Something like that you will do. You have to find one proper value, right? So whenever the value is too big, you need to trim it to 10 raised to 6, okay, to get your job done. Okay. So if you come to know that putting a is giving the range from 1 to 10 raised to 10 now, so now you will declare that putting a gives you a range from 1 to 10 raised to 6. Now you decide the second character. If you put a again here, you will see, so somehow you will be able to find permutation at 10 raised to 6 position. But this value can be very big now. So how to handle? You can write, like, if you do combinatorics, you can write it in this way. You have total f1, f2, f3 places, right? So from f1 plus f2 plus f3, you can just select f1 places. Then from the remaining f2 plus f3 places, you can select f2 places. And then from the remaining f3 places, you can select f3 places. Instead of writing it like this, you will write it like this. And don't worry, we will have only f1, f2 till f of 26 because we have only 26 character frequencies. Okay. Now, why is this beneficial? Why is calculating like this beneficial? Because you are calculating NCR in each term and you are multiplying each NCR. Now, in NCR, you can easily notice while calculating NCR, when is it becoming greater than equal to 10 raised to 6. If any of the term is becoming greater than equal to 10 raised to 6, you know that we have crossed the limit and need to stop now. Or if the multiplication of any NCR is becoming greater than equal to 10 raised to 6, you know you have crossed the limit, you need to stop now. So, this is how the things go. Okay. So hopefully you loved it, and if you want the D problem, you want its detailed analysis by me, then make sure you comment it in the video. Okay, so with the name of God, Ram Ram, hopefully you guys enjoyed it thoroughly. Okay.